Today we're going to talk about ratios and proportions. Definition of ratio. The ratio of A to B can be thought of as A over B, A colon B, or A to B. Here's an example. In the triangle ABC, the ratio of angle A to angle B is 40 to 60, which we can simplify to 2 to 3. The ratio of B to C is 60 to 80, which we can simplify as 3 to 4. The ratio of A to B to C, we wouldn't be able to make that into a fraction. We could think about it as 40 to 60 to 80, which we could simplify by taking a 10 out and by taking a 2 out of each, basically by dividing by 20. And if we divide each thing by 20, we'll get 2 to 3 to 4. And then A to C can be thought about as 40 to 80, which is 1 to 2. Good. How many kids are in each class total if the ratio of boys to girls is 8 to 5? Well, we can think about that as being 8 to 5. So we know the total of this would be 13. That might be one answer. We can also think about that ratio as being what? If I multiply the top and bottom by 2, I'd get 16 to 10. Maybe I multiply the top and bottom by 3 and I get 24 to 15. So some answers to this problem would be 13, which is the sum of 8 plus 5, 26, which is the sum of 16 and 10, or 39, which is the sum of 24 and 15. Example 3. A and B are complementary angles. In addition, the ratio of A to B is 2 to 3. Let's find angle A and angle B. Well, here's a table to get us started. So if we know the ratio is 2 to 3, we can write down what if angle A was 2, angle B would be 3. We could also have this be 4 and 6, 6 and 9, and so on. And so if you think of this as being twice something, this one would have to be 3 times that thing to have the ratio be the same. I don't know if that's helpful. But anyway, so I think so. So basically what you'd think about is you'd have 2x plus 3x. What does it mean to be complementary? C comes before S, complementary comes before supplementary, 90 comes before 180, complementary is 90 degrees. 5x equals 90, and divide through by what? 5x is 18. But again, the answer is find the measure of angle A and B. So angle A would be 2 times 18, which is 36. And angle B would be 3 times 18, which is 54. I think I said that right. 54 degrees. Good. Moving along. The angles in a triangle are in the ratio of 1, 9, and 10. Find the measure of each angle. Well, let's see. Let's remember that the sum of the angles of a triangle are 180 degrees. And if the ratio is 1, 9, and 10, we would simply set up something very similar to what we just did, where the ratio looks like this. And they sum to 180. So we'd get what? 20x equals 180, x equals 9. So the measures of the three angles, you'd plug in 9, so it would be 9 degrees. 9 times 9 is 81 degrees. And the last one, 9 times 10 is 90 degrees. Okay? All right, let's go on to proportions. A proportion is an equation that uses ratios. That uses ratios. Sorry for the messy handwriting. Some proportions are thought of, and an equation also has an equal sign in it. Equations have equal signs in it. So notice that all of these equations with equal signs have ratios in it. So we can think of how do we solve one. I like to write it like this. To me, it's a little bit easier to look at. How can we get from 3 to 36? Well, I guess you multiply 3 times 12. And so you'd have to multiply 1 times 12 to keep the fraction equivalence. So x would be 12. I multiply both things by 12. So one way to think about it is you'd get x equals 12 by multiplying the numerator and denominator of this thing to equal the 36. This one's a little bit harder to do in a way because it's a little more complicated. So we have the idea of cross multiplication where you multiply 3 times x plus 4. Oh, x minus 4, pardon me. And that would equal this one. And this is just a way to take algebra and solve fractions. And it would work if you did it step by step without cross multiplying. 3 times x is 3x minus 12 equals 2x. Maybe we add 12 to both sides. Maybe we subtract x from both sides and we get x equals, 12 again. Okay. And you could, of course, plug that in to see if that works. Okay, moving on. Next page. Properties of proportions. If you know that a over b equals c over d, and here's an example, 1/2 equals 5 over 10, you can also say that a times d, which we just talked about, which is cross multiplication, equals b times c. That's called cross multiplication. Let's make sure it works for this problem. 1 times 10 is 10, equals 5 times 2 is 10. Well, that certainly works nicely. The other thing that you can do in proportions is you can flip them. In other words, b over a equals d over c. Again, this is all in your textbook, the first part of Chapter 7, if you want to refer to Chapter 7.1 and 7.2. Let's flip it and look at it. 2 over 1 equals 10 over 5. Well, that looks pretty good. And the third thing, we'll call this the flip. And the third thing is you can look at the top, the ratio of the tops, the ratio of the bottoms. So a over c would also be congruent to b over d. And let's check this one out. And this is tops to bottoms, I don't know. Sometimes they help to have these tricks to play around with the ratios. So let's go ahead. So that would mean that 1 is to 5, which is top is to top, as 2 is to 10. And isn't that right? 1 is to 5, as 2 is to 10. That totally works. Here is some practice. I'll do the first one, and then I'd like you to do 5b and 5c. Okay, actually, I'm going to do 5b. 5a looks pretty straightforward. 5b, it looks like we have to do a little foiling. So let's go ahead and do it. So you cross multiply. So I have x times x is x squared. You have x plus 5 times x minus 4. And we want to FOIL that properly by making sure we multiply first times first, outer and inners, and the last. 5 times a negative 4 is a negative 20. Combining like terms. Oops, yeah, plus x minus 20. Okay, and how nice is this? If I subtract x squared from both sides, the x squareds are going to cancel each other. So I would just be left with, let's see, I guess when we want to leave the x here, so I don't like to do this in this black ink, but I will. The x squareds will cancel, and you'll be left with x minus 20. If we add 20 to both sides, we'll get x equals 20. Okay, and again, to make sure it works, you could just plug it back in to check it. Okay, so the rest of this worksheet has some examples of using ratios. So I'd like you, in word problems and in some algebra, I'd like you to try those, and we will check them in class tomorrow. Make sure you have your packet when you come to class tomorrow.